Welcome, everyone. Thank you for joining us for this session today. This session will be outlining a key premise that we've been working on and studying through Dr. Ranil Senanayaka's applied scientific work as well as restoration work. The premise of recognizing value for photosynthetic biomass and also segregating the ecosystem services market into categories defining photosynthesis, biosynthesis, and then tertiary ecosystem services. So, to explain to us how we are looking at things from the Sri Lankan perspective and also participating in the global restoration cause, I'll give you Dr. Ranil Senanayaka. Dr. Ranil will be sharing a slide presentation uh, that should take about 40 to 45 minutes of
Yes,
our time.
yes, probably yes. Thank you, Dehan. Am I here? Okay.
Yeah.
Thank you, Dehan. Okay, let me, without ado, move on to the presentation and I'll tell you what I want to talk to you about. Share screen. Okay, here we are. And okay. Can you see it? Share.
Yeah.
Okay. This is what I want to talk to all of you about. All of us are struggling to do environmental restoration, trying to heal the planet, to do everything else. And we are being told that there's no funds, there's no money. Actually, there is. And that is where we come in. And with Earth restoration, with our work, we have been finding out that globally, the economists have estimated a value of $215 trillion a year in 2011. I mean, consider this volume of money, right? This huge amount of funds is available for development, restoration, or any other work, but it is at the moment only in a theoretical sense. I would like to share with you today a concept called primary ecosystem services. And this concept basically will help us move into this market. It is based on creating wealth, based on, this is important, contracted primary ecosystem services, CPES. You will hear this as we go on. We do this by realizing the value of the ecosystem services as a positive externality into the marketplace. Because after all, whether we like it or not, we are in the modern marketplace and we have to, if we want to engage, we have to now talk in their language and deal in their terms. So let's go. What are ecosystem services? We've heard a whole lot about ecosystem services. So it's not, all right, the first thing we should do is find out what are ecosystem services. So if you go to Britannica, if you go to Wikipedia, this is what we are told. They are the outputs and conditions or processes of natural systems that directly or indirectly benefit humans or enhance social welfare. So there is this big description of what and how ecosystems help us. This is true. This is very right. But once we say, okay, ecosystem services, then we have to ask ourselves, what is an ecosystem that these services are coming from, right? How does that operate? So here is the ecosystem, right? In any ecosystem, right, energy enters the system through photosynthesis and is incorporated into plant tissue. This is what drives all ecosystems on this planet. And that is, solar energy is captured here by the producers, and then the respiration begins, primary consumers, secondary consumers, tertiary, on and on and on. This is how an ecosystem is organized. I would like all of you to keep this in mind, because as we go on, you will find that ecosystem services are being defined mostly by bureaucrats and people who do not understand ecosystems. It's very subjective definitions are coming out. So now it's incumbent on us to make sure that what we talk about is scientific and well-rooted in established knowledge. So this is what an ecosystem is. And we know that energy enters the ecosystem through its primary producers. Now, the primary act of life is photosynthesis. This is the process by which green plants and other organisms transform light into chemical energy. Britannica says, and it is a fact, it would be impossible to overestimate the importance of photosynthesis in the maintenance of life on Earth. It is the fundamental thing that keeps everything alive on this planet. If photosynthesis ceased, there would be soon little or no food or other organic matter. Most organisms will disappear and Earth's atmosphere would become nearly devoid of gaseous oxygen. So, photosynthesis keeps everything going. It keeps us alive. This is the most fundamentally important thing for people who work with living systems, whether it be agriculture, whether it be forestry, whether it be ornamental farms, doesn't matter. Whatever we are doing, the importance of photosynthesis for the maintenance of all of our systems is fundamental and critical. Now, see, primary productivity. So we spoke about primary productivity. What is primary productivity? It is the rate, the speed at which energy is converted into organic substances by photosynthetic producers. These are called photoautotrophs, which obtain energy and nutrients harnessing sunlight. So this is what happens, a leaf then takes in sunlight, uses oxygen, uses water and carbon dioxide, and gives us oxygen and a sugar. This is basically the product of photosynthesis. This has been called actually the creation formula, basically because this signifies what creation is. Now, the act of primary productivity is the thing that creates the first of the ecosystem services, which are called primary ecosystem services. And these services support all the subsequent ecosystem services that come after it. So what are the primary ecosystem services? The capture of solar energy, the production of oxygen, the phytoremediation of groundwater, and the capture of carbon over time. Now, this brings us to what we should look at also very clearly when we are looking at living systems. Living systems are a combination of production, which is photosynthesis, the producers, and respiration, all the rest of life that uses it. The first formation of solid matter, energy, is through photosynthesis, where energy is converted into organic substances. That's the first step. As soon as this step is done, then biosynthesis begins. This is the biological life taking the energy that was captured from the sun to make all the plant secondary metabolites. Could be lignin, cellulose, alkaloids, bitters, all of it. So this is the second step. The first step is the primary activity, primary productivity. So now we go to the current definitions of ecosystem services. Now you've heard the terms, everybody, the whole world is talking about it. This is valuable and all that stuff. and they're divided into all these things. If you look at this, you'll see in a thing called supporting ecosystem services as primary production, soil formation, nutrient cycle. Primary production should have been outside, should have been the primary thing. Then the supporting could have been nutrient cycling, soil formation, etc. The people who have put this together have forgotten the fact that the first ecosystem service comes from photosynthesis. Let's look at this again. And then because of that, that's an old thing. This is what it has sort of snowballed into. This is this, I think, is basically a product of lots of committees and people sitting and doing committee discussions and all that stuff. All this does not recognize the fact that all ecosystem services have to begin with the PES, with the primary ecosystem services, with photosynthesis. They've forgotten all that, and they're into all these things which are totally subjective in terms of trying to measure and look at and value. So we need something solid. We need something that is objective, non-subjective, and that we can put a measure on, and we can then continue to monitor it. This is what is required. So how can we do this? As all ecosystem services, as we discussed, begins with the leaves of plants or by the photosynthetic biomass, which creates the primary ecosystem services. Now, biological fixation happens this way. Trees there, sunlight, primary producers, then it goes on to the consumers who respire carbon dioxide back into the atmosphere, tree collects it, etc., into decomposition. This is the cycle of carbon on this planet. But the most important thing is that photosynthetic biomass creates primary ecosystem services. So if photosynthetic biomass creates primary ecosystem services, then obviously photosynthetic biomass is a very useful thing by which to measure primary ecosystem services by. So then we should look at it and see, okay, can we calculate this? Can we look at this? This is how we look at primary ecosystem services through leaf weight as a photosynthetic biomass proxy. Why leaf weight? Leaf weight because the photosynthetic biomass cannot exist by itself except as a single cellular organism, algae or diatoms. To exist on land, they need to be contained in something, and that is the leaf. The leaf provides the armature and the structure that holds the photosynthetic biomass, and therefore we are going to use the leaf weight as the proxy for calculating a PES. So now look at this. It takes 6 molecules of carbon dioxide joining with 6 molecules of water in the leaf to capture that energy from the sunlight. When the energy is captured, it gives us a simple sugar and oxygen. So if this is the primary ecosystem service that it does. And so therefore we say the gain in the weight of leaves at time 1 to time 2 is equal to the photosynthetic biomass. That is the total chlorophyll content and the armature that holds it. Now, if you look at it, there is usually a ratio of 1 to 6 for dynamic carbon and for oxygen. If you'll see, it takes 6 molecules of carbon dioxide, give us 1 of carbon and 6 of oxygen. And we have the dynamic carbon and oxygen, and we also have a ratio of 1 to 600 for every carbon molecule fixed, for water. This is because in a leaf, it takes 100 molecules of water to mediate the photosynthetic activity that goes on in the leaf, and this water is released out of the leaf through the stomata. So these are the two things that the three things that we have in the operation of a leaf, and they can be weighed and measured: dynamic carbon, oxygen, and water. Now, when we are putting value on these, variables have to be considered. And this is the future research, and that is the photosynthetic biomass time. That's the residence time of a leaf. Does the leaf exist for 6 months and fall off? Does the leaf exist for 1 year? Does the leaf exist for 2 years? This is the residence time. Another value factor is the efficiency of its primary productivity. And this is all the new research that we are building up that will help us assign different values to different species. At the moment, we are looking at the general equation, and we are looking at the general weight of the leaves of species as measured in the field. Now, here we have to ask ourselves a question: are these PES, primary ecosystem services, can they be looked at as externalities in agriculture or forestry? And then we ask our questions, well, what are externalities? Because, externalities are the language of the economists when they're looking at processes. Externalities occur in an economy when the production or consumption of a specific good or service impacts a third party that is not related. Now, here's some examples. Negative externality is when a consumer, or when consuming or producing a good, causes a cost to a third party. Example is air travel. Obviously, you're driving a car because somebody else has to pay the price. That's the negative part of the negative externality. Positive externalities is when doing something, when consuming or producing or doing something causes a benefit to the third party. Example they have given here is walking to work reduces congestion. Another very, very large area of positive externalities to be looked at is with trees. Growing trees provide positive externalities that occur when a third party benefits at no direct cost. So we grow the trees and somebody else benefits from the shade, somebody else benefits from the oxygen, we benefit from the tree. This is a positive externality. So when we consider trees as positive externalities, suddenly we find there's a whole lot we seem to have missed with trees. Well, one important positive externality is the function of trees that clean groundwater through transpiration. See, all water, all groundwater is polluted to one degree or another. This is because water is a universal solvent. As soon as rainwater falls on the ground, it combines with whatever materials it can dissolve in the ground. And in many areas, the groundwater is positively toxic to drink for human beings. But plants and trees growing in the area, what they do is they absorb the water in the roots as clean water, filter it and move it through the system and release it through their leaves as absolutely pure water, evaporated to form clouds and to form rain. This is an amazing positive externality of growing trees and plants, which has not even been considered up to now. Trees and plants in this can clean groundwater at a rate of 50,000 liters per large tree and add this water to the atmosphere, basically to come down later as rainfall. This is a positive externality at no cost at all to the third party. Here's another. When we have leaves, the leaves of plants produce what are called cloud condensation nuclei. Now, all clouds on this planet in nature has been formed largely by living organisms. Yeah, all those huge clouds, storm clouds, all that, created by living organisms. How? Why? Over the sea, there is a compound created by the phytoplankton called dimethyl sulfide, DMS. All of you know it when you go to the sea and you smell that fishy smell, dimethyl sulfide. That is the cloud condensation nuclei over the ocean, and the water in the air, in the atmosphere, needs this little nucleus to condense around. On land, trees and plants from their leaves put out biological particles and aerosols. They move into the atmosphere and they create volatile organic compounds and secondary aerosols, which become cloud condensation nuclei. Here you see a picture of how clouds are forming over the forests that are putting out cloud condensation. So the more forests you have, the more trees you have, the more clouds you will be able to create in your local area. And this is also another valuable thing that we have to consider as a positive externality. Here's another positive externality. This is the value of the evaporative cooling by the leaves of trees. So leaves of trees are doing all these things. What is this that they're doing? They are cooling the environment. USDA has computed that one tree working on a sunny day produces over 1,200,000 British thermal units a day of cooling. And an acre, 540 million British thermal units a day of cooling. In a future that we are facing, in a warming future, this aspect of trees and leaves, again, are going to be critical, and it needs to be addressed as a positive externality. And leaves are the only production system on land that supplies us oxygen. The creation and destruction of molecular oxygen in the global commons was at near equilibrium. But since humanity came and we started industrialization, this is what is happening to the atmospheric oxygen, while carbon dioxide concentration keeps rising. These have to be addressed. But what is the thing that gives us all these primary ecosystem services? In terrestrial ecosystems, they occur, as we discussed, within the leaves of plants. So this means that looking at leaf weight is an ideal proxy for computing the primary ecosystem services that come from trees and plants. So this provides a measure that is obvious and verifiable, but requires a lot of fieldwork. As you see here was a team in Myanmar. They had to go, you have to go to trees and plants of a given age class, say 1 year old, excuse me for a minute. Just a minute, I'm at a meeting. Say 1 year old, right? Then what we do is we go and pluck all the leaves from the 1 year old tree, wait. That's what they're doing here. Then they go to the second 1 year old, the third, until they've got a statistically significant sample, about 10 plants. Then they go to the next age class, year 2. This is laborious work, but it hasn't been done before, and it had to be done. So Earth Restoration has now gone out and measured in this laborious manner, and we've got the growth curves of the species up to 4 years. And this has now become an easy system and an implementable protocol in any country, anywhere in the world. Now, look at the leaf functions. Look at this picture here. Under the current economy, only the fruit has value. And it only has value if you pluck it and take it to market. And somebody might say, yeah, the leaves also have value, but you've got to pluck it and take it to market. Under the current economy, in recognizing primary ecosystem services, if you recognize the primary ecosystem services, all of a sudden, the leaves also have value. But leaves have value only as long as it is attached to the tree and living and doing the function of photosynthesis. So now we are putting a value on something that is living, and the life action of that thing is what we are putting a value on. The old economy put a value on dead things. You pluck it and you send it to the market. This economy puts a value on life. And that is what makes this economy unique and productive and hopefully beneficial to all of humanity. Now, I'd like to show you something else. And that is, why are we using the leaf as the proxy? Because you have to put out, there's a whole lot of other weight also. See, it's because if you look at the relative abundance of photosynthetic biomass, on land, we have the largest amount of photosynthetic biomass. Oceans have only a little. Then we look at the oxygen production of the land and the ocean, and you see a surprising result. The ocean produces much more oxygen than the land. See? Why? Because on land, the oxygen producing material, the photosynthetic biomass, can't exist free floating like in the ocean. They have to create a basket or a structure to hold it, which is the leaf, which has to be on the tree. And all these units that maintain these things have a cost. It's called respiration. Energy is spent in maintaining it. So the land material uses a lot of the oxygen that they produce in respiration, but this respiration is critical for maintaining all the ecological services, including the cleaning of water that can only be done on the land. So while there are these differences, there are the trade-offs. That's why all of you who are working in this area has to become very, very cognizant of the processes that we are looking at. Now, the value of global ecosystem services has been, as I said, looked at, $125 trillion a year, not dollar, that is a thing. And this was issued in 2011. And what they looked at is they looked at the various ecosystems and looked at the flow value across it, and they assigned a value to it. So, but although they have assigned a value to what is happening out there, nobody up to now has been able to capitalize on it. All these values that I demonstrated. And that is how, and why, that is how primary ecosystem services has been utilized by Earth Restoration to create a unit of measurement and a unit that can be monitored and reported upon that has intrinsic value in and of itself, because we have created a contracted item. I think the ecosystem services involvement with Earth Restoration, Jehan, are you going to take that?
No.
You're going to, okay. We should, if they want, we can have another presentation of ER and how ER does its field work. This was basically to present to everybody the whole idea of primary ecosystem services and the value that there is and ways and means of which we can address it. So now we are open to questions. We are open to discussion. That was what this thing was about, right? At Earth Restoration, we are already out there trading. We are moving right in there. And we'd like to invite everybody else also to ask questions, to come in, because the more people who are aware and the more people who can create more and more market possibilities based upon primary ecosystems, the better it will be for the entire planet and its sustainability. Questions?
Thank you, Dr. Anil.
Sure.
We have another short session from about our field processes, and that
Oh,
will
that's true. Good.
a 3 minute little break and time to for our audience
If
to.
there's any questions, we're happy to take them.
Yeah. So we'll start the next session in 3 minutes, and we're happy to take questions. Thank you.
Okay.
If there are no direct questions, we'll start in 2 minutes. Thank you. The chat window is also open for anyone.
$112 trillion US, and there's no questions?
Don't let the Rajapaksas know about it. They'll try to steal all.
No. Tell them they'll run and protect all the trees in the country. They say, muggy. That's why we'll want 10% from all the trees.
I think, Dihan, you will explain the process of contracting and engaging. Like if someone wants to participate, where should one start?
Well, you should definitely approach us, and then what we do is we do a very basic survey and feasibility study now because our units are contracted to benefit tree care and economic premise. We are looking for communities and people who will benefit from this project, from this kind of scaling. So there will be some aspects that we'll be looking into when we work with collaborators. I'll go over that in just a moment once we follow from Mr. Samira Abhiratna's presentation of our field protocols and the scientific methods. Thank you. Samira, if you're ready, you can go ahead.
Thank you, Deha. Shall I share my screen?
Yeah, please go ahead.
So, good morning, all of you. So, as I think Dr. Ranil explained about the background of these primary ecosystem valuations, what is currently practicing by the Earth Restoration. So my part is how we are going to value these primary ecosystem services using our field protocols. So currently, actually, under this primary ecosystem service valuation, the initial part is begin with the measuring the photosynthetic biomass of a given tree unit. We call it as a tree unit. As a single tree, we call it as a tree unit. So this is my presentation outline. So I define the primary ecosystem servicing values of life force project and ER methodology of estimates, and what is the existing algorithm and algorithm currently we are using for the estimations. And now we need to establish a generalized methodology. All the scientific communities and expertise can accept it. So as you know, so I don't want to talk about more about the universal mechanism of photosynthesis. So we know all higher plants in the planet, so they get carbon dioxide and water from the roots, and then do the processing as photosynthesis and produce what do you call biomass. It may be a glucose or something, and plus pure oxygen. So actually, when we are looking forward to the ER methodology of estimating primary ecosystem services, so it based on the photosynthetic biomass of the early stages of the plants. So so actually what we the current methodology is what we are using here, the photosynthetic biomass of a tree for a given year, for a given time period. So we measure the number of leaves and get the fresh weight of the leaves. So this is the equation what we are using here. And then so actually at this moment we are using the fresh weight of the leaf sample of a tree, and so we consider it as a photosynthetic biomass. So so I put this question to our scientific forum, for this forum. So so my suggestion is taking the fresh weight of a green leaf, then if we can consider the dry weight of a leaf, I think that is better than the fresh weight or the green weight, because we know in the plant physiology, the always the photosynthetic biomass values always correlated with the leaf dry weight, or the what we call the constant oven dry weight. So due to this internal respiration and other energy use biological functions inside of the leaf. So so I put this question into our forum. Dr. Ranil and Dr. Nalaki is here, and Professor Ann Jung here. So they can suggest and they can give their ideas to this forum. And so actually, so our new it's a new thing. Actually, we need to highlight the dynamic carbon capture, what we call DCC, through this through this life force project. And this so actually I am so I went through some kind of a universal equation of the photosynthesis, and so I represent it as a one portion of photosynthetic biomass is equal to the one portion of captured carbon dioxide. So sorry, six portion of captured carbon dioxide. This is the general equation what we can use to estimate the dynamic carbon capturing ability of a plant. So then the main derivatives of the PES, that mean primary ecosystem services, are the at this photosynthesis. So currently we are using this methodology, and actually this reference is valid to the cyanobacteria and green algae. So this also I highlighted in the forum. So if we are going to a generalized or some kind of universal methodology, the photosynthetic process of the cyanobacteria or the green algae can we compare with the higher plants? Yeah, actually we can compare into some extent. We know all are following the same mechanism of photosynthesis, but they are acting different in different environmental conditions. So and if we are going to some kind of a universal equation, so we can quantify the oxygen or the water production as 1 portion of photosynthetic biomass is equal to the 6 portion of captured oxygen and pure water. Okay, then so actually there is some kind of questions arise. So when we are doing the calculations, as so our ER methodology, this currently we are using the algorithm. So that is for some especially quantification of oxygen and the water, that is applicable for some trees and shrubs which are located in different geographical regions. So is there any uniformity when we are using this, or the best method is going for a universal mechanism, as you can see in this slide. So I think the PES calculation of the ER methodology, now it's understanding for yourself. So any question, and you can any question you can put into this forum, and I'm very happy to answer the questions, and you can put your suggestions at the same time. Thank you very much. They hand this over to you. Thank you.
Great. Thanks a lot, Samira. So
I can.
I guess
I'd like to go and just, I've posted my 2 responses. One is that the fresh weight photosynthetic fresh weight must be used, leaf weight must be used, because most of the photosynthetic biomass will be lost on drying when you dry it, because it's mostly water in the leaf. So we are looking at the living leaf. So if we are putting a value on the living leaf, then it's the fresh weight that must be used. Secondly, on the universal formula, yes, we build up a universal formula, but as I pointed out in my presentation, there are many variables we can add as modifiers, as modifiers, which will modify and increase the value or decrease according to the performance of that particular plant or tree. But the formula is universal, that's basic. You use that, and then you use the research methodologies or the research information you have to add to or bring in the other variables that will add or subtract the value of a universal formula. I suggest that's how we go forward. Yep. Anybody else?
Yes, this is Nalaka. I have a small clarification. that apparently you are trying to measure the photosynthetic biomass in terms of the quantity, that means weight of total leaf of a particular plant, and then are you going to relate it to the carbon? Would you please explain it little more so I can add some more comments? Samira?
Yeah. Yes, doctor. Actually, doctor, now, so at this moment, we are starting from the measuring the photosynthetic biomass using the this fresh leaf weight of a plant. So, so then the measured value, then we are going to apply for that universal equation. Can I share the, please wait, I will share the screen. And here, sir. So this, that means this C6H12O6, that is equal to the this measuring value, and this measuring value is a general this stoichiometric relationship we can apply. So one molecule of this photosynthetic biomass is equal to the 6 molecule of carbon dioxide. So that is the theory behind that, Dr. Nalaka. And actually we want to some kind of a clarification. The expert is like you, but this is generalized, or we have to modify this.
Yes, I think this is a good starting point. Yes, we also, I saw in one of the slides that you are going to consider the allocation patterns within a plant. Like, so if you have X number of leaves or X kilograms of leaves in a particular plant, and whatever the thing manufactured they are in going to be allocated to the plant for further development of new leaves, growing height and girth, and also into the roots. Are you going to consider those allocation patterns, particularly when you are trying to revise your or modify the equation as Dr. Ranil mentioned?
No, we are not. We're basically, at the moment, what we're doing is we are measuring at one time per year, and we are looking at the weight difference between time 1 and time 2. At the moment, that's the best we can do. Certainly, we can do many other finer patterns, and as for value variables, it is, for instance, we got temperate leaves, things that are on the tree for 6 months and then fall off. Then other trees, Amazon, Sri Lanka, some have 2-year-old leaves. So we have to allocate variables or values to these variables, and then develop the formula of valuation depending on the final allocation of the variables. But that's what we need the scientists for. We need the scientists to come in and start measuring these variables that we're going to be looking at. A jack tree is 0.5% more effective in primary productivity than a mango tree. I mean, for theoretical, I don't know. But none of this has been done. So we have to do all this research into the future. I'm just trying to provoke the research.
Yeah, good. So if you're not like considering the fine detail allocation patterns within a plant, I would actually suggest, sorry, I have a little bit of cough. Yes, what we have to consider, actually, there are some established relationships within plant canopies of, for example, rainforest, that are very tightly correlated with the overall productivity of the entire ecosystem. For example, the leaf area index. So I hope, since there are a couple of us in the meeting, let me clarify what is leaf area index. which is actually the total area of total one-sided leaf area of a particular plant per unit area. That means per 1 square meter, if you be in a forest and look up the sky, there might be a number of leaves sitting on top of our eyesight within a 1 square meter. So for tropical rainforest, for example, this is most of the time above 6. It's a ratio, and that ratio is very tightly correlated with the net primary productivity of a particular ecosystem. For example, in a rainforest, there are many stratifications, so many leaves are on top of each other, covering those below. And if you compare that with a tropical dry forest, which is very sparse and few number of leaves in a particular spot, which has a less leaf area index. So if we go by leaf area index rather than looking at the fresh weight of a leaf, in my opinion, that is more established and recognized. So if we consider yes,
Dr. Nalaka, we are not looking at LAI because we are looking at the weight of leaves from year 1 to year 4. That's exactly why we chose year 1 to year 4, because beyond that, we need to get to point cloud modeling and we have to get to LIDAR, etc., to get the canopy measures. And that's where we need the researchers to go and give us this data. We have the data for year 1 to year 4. We need the other researchers who are looking at the other forms to come with the techniques and ways to go beyond year 4. That's we're totally open to. And it's not only LAI, not the leaf area index, we are interested in the leaf mass, because we are looking at the production of
total leaf mass of a particular plant.
If we can get total leaf mass, and that's why I'm looking at LIDAR and point cloud modeling, but that's in the future. At the moment, we have what we can physically deal with, year 1 to year 4. And what I'd like to do is grow on that.
So at this moment, so you are collecting this information at individual plant level or tree level?
Look, we have done that. My goodness, we have done that. And we have got statistically significant for each age class also.
Okay. Yeah, then I think still you can establish relationships with the raw data you have to the parameters that you want to estimate. So along the way, at some point, maybe other allometric measurements like the tree stem size and even LAI, those parameters can be pumped into.
Dr. Nalaka, it will be great if you can sort of join us and help us in sort of, designing some research questions into this area, because this is the future, and it's superb to have somebody who's, who's already involved in that to help get in there.
Yeah, we have done actually quite a lot of work in Dambul, where there is so-called arboretum, sand from arboretum. So we have calculated the photosynthetic rate. We have all those equipments from intact leaves representing the whole canopy strata, starting from canopy.
Oh, yes. No, we're very interested in that. Because Dr. Nalaka, the one thing we are finding out is that most of our trees basically come to a compensation point and flatten off in their growth, as you know. At the compensation point, basically, there's no net production of oxygen. And now in most mature forests, especially in rainforests, when the compensation point is reached, there's a huge load of epiphytes and vines that actually do not have such a strong compensation point. Epiphytes don't at all. And they then contribute to the net release of oxygen from these formations. So we should look at the formation, but that's broad research. I'd love to get there sometime, that's broad research. And I'm very happy to work with anybody who wants to get in there and set up any projects. It'll be great. And since we got Refa here, do you know that in Ecuador, in a forest that reaches compensation point, the epiphyte load, living epiphyte load is 16 tons. 16 tons of living epiphytes per hectare when the compensation point is reached. So these are amazing figures. And these are figures, I love researchers to start developing to present to the world.
So we'll just wrap up this session with a small presentation by myself with regard to what our project is benefiting the communities with, and how we have strategized to value these transaction processes through a smart contract that we have developed. Hang on a moment while I just share the screen. So the term ecosystem services, just like the word forest, has been ill-defined. It has led to much confusion. And what we would propose is to begin addressing a term in a scientific and common sense manner. So we've been through the scientific way, and I guess the other part was to integrate a very practical way to make people understand that, hey, this is a process and you are a part of this process, and you will be evaluated through this process, and that you will benefit through the evaluations that are done through this process. So we decided to evaluate and give value to the living leaf. We've studied living leaf patterns in over 40 tropical tree species that have been available to us. And then we have bridged a system. We have designed a system, an operating system to transact fiat finances, money coming in from investors, into this project in return for a new form of capital, or a new reporting formality on the value of primary ecosystem services that are generated by a tree unit, specifically the photosynthetic biomass component of a tree unit that is growing. So how we do this is we have a landscape that we have recognized as a potential project site. This particular example is Belipola analog forest and the home gardens surrounding it. Each of these landscapes, you can see here the perimeters marked. Each of these landscapes are managed by myself, Mr. Samira, who are in charge of this project. And each of these perimeters, each of these lands, each landowner has a manual seeding contract, primary ecosystem services value seeding contract. So legally, this is what this contract says. It gives you a location, an identity uh, to one of these territories, and this is the owner saying that he or she accepts to the investment of a tree unit on his or her property and undertake the responsibility of maintaining it. Our company, EarthRestoration, will conduct performance monitoring on the units placed on the land for 4 years. The landowner will be paid annually for the maintenance of that unit based on the weight of its photosynthetic component of biomass. For this consideration, I give the primary ecosystem services production of each unit owned by me to the assigned investor and a reporting ledger. So this contract is what we have digitized through a mobile phone application now. Uh, let's assume that this is one of the tree units on that on a property there, one tree unit. This is a durian tree. We know we are we are looking for its performance in the first year. It has about this much gain, and this is about 16 grams usually. So then 16 to about 144, there's a gain of about 120. So we verify that through our mobile phone application, and the digitization of that contract is this landowner registration, and it's an automated thing where each time we monitor, this landowner is recognized by the system, and for every verification, annual verification, the bank owner, the landowner gets paid uh, for taking care of these trees and participating in this project. So that's a little brief on how we engage with the farmers and the communities in designing our primary ecosystem services uh, or contracted primary ecosystem services landscapes. We call these Earth Restoration blocks, and you can get in touch with us about designing your own block. Right now, we are located in the Uber province in Colombo, sorry, in Bandarwala, and we would like to extend, but it's based on scientific research and various premises that we can design for our for establishing these models. Thank you. If there are any questions, if not, please note that I will share all of these informations, and we invite you to participate in the ongoing discussion through Beripola Arboretum website, as well as the Earth Restoration website that we will be.
Tejan, may I ask one more question? Hello?
Yeah, go ahead, Nalika.
Yes, it's great that you are kind of like recruiting potential landlords to the system. So as far as I saw, you are kind of crediting in terms of plant biomass as you had first defined it. Will you be considering other parameters like, for example, richness, species richness in these home gardens?
We do some basic surveys, but they are not considered into a model. They are not considered into our evaluatory model because we have a premise for verifying the primary ecosystem services. And that is the specific component of photosynthetic biomass. So let's take a farm. Normally, a farm is full of photosynthetic biomass, but there it can be at the first cereal stage, or farmland, or like salads and leaves, and that kind of thing. Whereas the the stratification, both above and below ground, may not always be present. So we're looking at verifying these components that are more perennial, that are looking to go into a long-term establishment phase.
Yes, that's correct. So, when it comes to the farmer level, if we are paying them in terms of plant biomass, there are, for example, fast growing species, many fast growing species that they can turn up a lot of biomass end of each year. So they will, if we do not consider the diversity aspect, perhaps they can select a particular plant species and grow all over or in many places. So my
The
suggestion is
the
actually to consider the
for the
diversity as
engage
well.
the thing with engaging with our program is about having knowing the performance of trees and contracting the performance of those trees. Now, within the system, how we place those trees, we always use a baseline survey methodology that we use in analog forestry. So
So,
we
so the
don't
plants are kind of predefined by
establish
your
one.
team, right?
We don't,
The type of plants
yes,
that are going to be used is predefined by your team.
yes, we
They
have a selection
The
that
farmer can
the
choose also,
landowner can also
can choose. Yeah, landowner can choose. And
yeah,
also
you
the
have a
B2B
pool
ratio.
that farmers can choose. Okay,
Uh,
that's good.
And also we try to maintain a high B2B ratio. Yeah, you mentioned that. And because we insist, if there's a large area, we insist on a high B to B ratio. And that's how we ensure the maximum biodiversity within our design.
Mhm.
this session can continue, and we will open this forum to others also for our next session. So please stay tuned, and also if you want to email us with any questions or continue this chat, I'll be prompting you with the recording of this session.
Right.
All right. Thank you very much, folks. Have a great day. Thanks, Dr.
Thank
Ranil,
you.
for your knowledge,
Thank
and
you
thanks
all.
everyone for
Thank you.
their part.